we are going to do is first, day 2 worksheets, BigO linked list versus array list, and Iterator worksheet. And the second one, we have lab, Iterator Lab. And BigO linked list, array list, it has a front and back, and there are lots of questions to think about. And for the Iterator worksheet, you need to look at the Iterator worksheet.java, which is already written. So what you need to do is you can just comment out. If you want to solve, look at for the question 3, you can just put the debug mark. Then you are going to click debug after you uncomment it. Then if you go down arrow, you are going to see the list is made. First time empty. After you move line 9, you're gonna see A is added. There is 2 pointers, first, last, and actually the list pointer is also pointing the first item of this. Then B is added, C, D, E are added. Now we are going to look at what iterator does. So you have the list here. Then you are going to look at the iterator. So you are going to drag it. You are going to see it is pointing the first item, and next is also pointing the first item. In that case, you are going to put caret before A. So next pointer is before A. Then after in next is done, now the caret is before B. So if I drag A, not this drag, you're going to see now next is pointing before B. So pointing B actually. Then after you remove, after you have another next, you're going to see now next is pointing C. That means next is between B and C. Then when you remove, you are going to remove just you return the value that was the B. So removal will delete B. So you're going to see A, C, D, E. Then next is pointing C. That means pointer is between A and C. Now 일단 next. Then there is now pointer is pointing D. Next is pointing D. Then when you add, it's going to add just right before the D. So you can see that X is added right before D. For the BigO efficiency, you can see that there's a linked list, array list. Linked list is our DLL lab, and array list is our TJ array list. Depends on, I want you remember how you wrote each code, then I want you write down the BigO efficiency in the table. Then also, number 1 through 6, you are going to write all the answers and reasonings, BigO efficiency, then explain why. First, the BigO values for linked list and array list. In the linked list, whenever you are supposed to search the index, it is BigO n. And everything else, like adding last or getting last or first, are all BigO 1. In the array list, whenever you have to do shift to BigO n, that means only at the special case you are going to have a BigO n, like when the my array is filled, and if you want to add another item, you're going to make the array as bigger. So sometimes it is BigO n, but not all the time. After you add first 10 items, first 20 items, and first 40, 80, 160. So not really affect to your BigO efficiency. Then the next 1 and 2, get method in the linked list BigO n, so it is BigO n square. Whenever you remove in the array list, you have to shift, so it is BigO n square. But if you are using iterator to remove in the linked list, it's gonna be BigO 1, so that is BigO n. Then 3, 4, 5, 6. In the array list, you are able to use binary search because it is ordered solid array list. But in the linked list, it's impossible to use a binary search because it does not have index numbers. inserting. So when you find the location, then shift the data. So it is separately after log n is done, then log n, then BigO n. So BigO n is the final efficiency. Same thing for delete, same thing for insert resize. Then the rest of them, I think most of you did a great job. So you're gonna check the answer later. Then the other one is Iterator Worksheet. You can make iterator or list iterator. Either way is okay. Number 2, you're supposed to use only iterator method. So you're supposed to use has next and next. Then number 7, if you understood number 6 and number 7 is easy. You can look at quickly. Number 8, I'm going to share the answer first. Yes, yes, yes. Oh, yes. Then the reasoning, you can think about that. Number 9 is the million stars. I have to talk about that. Number 9 is the most important. Let's think about I have to delete box B. Then index 1, index 2 both has a box. When I visit index 1, index 1 will be deleted, then it will shift to the left. So now index 1 has the index 2 has, index 2 will have, index 3 have. Then there is a problem. For loop automatically increases I, so I becomes 2. That means you're gonna skip the second box. So you cannot remove the second box. In this case, to fix this one, whenever you remove, you can decrease I. After you remove I, you can decrease I. That means you can restart from the current position. So that's what you need to think about. Then the second one, there is a rule. Look at the student B and student C. Student B is using iterator, so it is using iterator's remove method. In this case, it's okay. But while you are using iterator, because for each loop is using iterator, then if you are using the list remove method, it's not okay. This means by using two different ways at the same time, concurrent, you want to modify. It is violating the rule, so it's gonna cause concurrent modification runtime error. So remember that if you use iterator, use iterator method, like student B. If you use array list method, like a size with the for loop, you're gonna use list method. And at the time, you're going to reduce the I by 1, decrease the I by 1 whenever you work on the I. Then C, never do this way. This is wrong. Then number 10 and 11, I want you to think about your own answer. Then Iterator Lab. Actually, this lab is very easy if you understood the Iterator Worksheet. If I explain just a little bit about this lab, if you look at the replacing negative delete 0 method, it says you need to return the array list. Actually, you can change your array list A, then return A. It's possible. But remove duplicate, it is recommended to start with an empty array list. So you're going to make the new array list and copy it, then return that new array list. There is the sample output. This one is given only when you download the shellcode from the Google Classroom. So if you have a correct output, you can turn it in.